everyone. So today we're talking about lesson 610, which is the discriminant theorem. And as we talk through what the discriminant is and what it does for us, I want you to get that I'm really not teaching you anything new today. Today is a really good just kind of pulling everything together type lesson. All right. We are going to go back into the land of quadratics and thinking about parabolas and things like that. But we're also going to relate it back to the quadratic formula and the imaginary numbers and some of that stuff we've been talking about. So probably first thing you need to know here is when I refer to roots, what am I talking about? And roots are the places where the graph of a function crosses the x-axis. So I'm going to draw one here that's not a quadratic on purpose. Okay, so if I had a graph that looks something like this, these spots here would be known as the roots, okay? Now, we've called those something else before, right? Think about what those really are, those spots that I circled. Those are the x-intercepts, okay? And we also sometimes call them zeros. So I just want you to know that all of those words refer to the same thing. Zeros, x-intercepts, roots. They're all talking about these spots here. Okay, they're that important that they get 3 different words. Now, let's remind ourselves what we know about finding x-intercepts. At the x-intercept, anytime in any graph, if I'm standing at one of these points where I'm crossing the x-axis, I know y is equal to 0. Okay? So if I'm looking to find what the roots are, I'm going to plug in a 0 for y, and then I'm going to solve for x. And when I'm talking solving in terms of quadratics, meaning anytime I'm working with a parabola, and I realize this is not a parabola, but if I was working with a quadratic and I'm talking about solving, that's going to involve, my friend, the quadratic formula. Okay? So all of this kind of loops back around to quadratics and the quadratic formula. Okay, let me grab a different color here real quick. When we're talking about quadratics, okay, and remember quadratics, the graph of those are going to be parabolas, okay? There are 3 different possibilities in terms of the graph. So I'm going to kind of sketch 3 graphs here. Okay? There's 3 different things that can happen. Probably what you're most used to is a parabola that kind of comes down and comes back up. And then you can see that here we have 2 roots. All right? We also sometimes have parabolas that kind of just sit right on the axis, okay, where the vertex is the x-intercept, okay? And so in that case, you only have 1 root. And then sometimes we also have floating parabolas that don't ever cross the x-axis. And in that case, you have no roots. So these are the only 3 ways that you can have roots in a parabola. You can have 2 roots, you can have 1 root, or you can have no roots at all. And of course, we know these parabolas could also be tipped upside down, but the same thing would hold true. Okay, so now let's talk about what the discriminant is, and then I'm going to come back up to these pictures and talk about how that refers to that. The discriminant is, well, here's the expression for the discriminant, and then we'll see if it looks familiar to you. B squared minus 4ac. And hopefully that rings a bell, okay? The discriminant is the little piece of the quadratic formula that's underneath the square root. So if you think about the quadratic formula, and maybe I'll kind of write that up here. X equals negative b plus minus square root b squared minus 4ac all over 2a. So the discriminant is this little piece right here, okay? It's the piece underneath the square root, all right? And the word discriminant, I know you hear like discriminate in there, and I know that has a very negative connotation, but quite literally the word discriminate means to tell the difference between things, okay? And again, I realize society-wise it's got a whole different meaning to it, but this Latin root here really means to tell the difference. So this little piece of the quadratic formula is how we can tell if we're dealing with this situation, or this situation, okay? And if you think about it, this is the thing that lives underneath the square root. So if that value is positive, all right, if you end up with a nice positive number underneath the square root when you're talking the quadratic formula, oh, I'm sorry, you can't see this. If the discriminant is positive, you're going to end up with 2 real roots. Okay, so that's this first picture from up here. If the discriminant is positive, this is the situation you're going to be in. Because if you end up with a positive number, I guess I should have just written the formula here. If you end up with a positive number underneath the square root, then you're going to do the whole split. You know, you're going to have negative b plus this number, negative b minus this number, divide by the 2a, and you're going to get 2 different answers. You're going to get an answer here and an answer here. Okay? If the discriminant comes out to be negative, okay, that's when you end up with imaginary numbers. Okay, you're going to have imaginary roots. And so we would say no real roots. Okay? Because if you have a negative number living under here and you take a square root of it, you're going to end up with an imaginary number. That's this situation here. That's your floating parabola. Okay? The roots are imaginary. Look, they don't exist. This thing never crosses the axis. So in this case, the discriminant would be negative. So how does this happen? How do you end up with only one root? Okay? You end up with only one root if this thing here works out to be exactly 0. Okay? Because if this works out to be 0 and you do plus 0 and minus 0, those are both just going to come out to be the same number. So you're going to get 2 of the exact same answer. And so that's when this happens. And we've kind of talked about that a little bit before. All right? Again, all of this we've talked about before. We've talked about how when this is positive, you get 2 answers. When this is negative, you get imaginary answers. But it's just putting it all back together with the quadratics here. This, by the way, would be 1 real root. Okay, so kind of just to summarize everything that we just talked about. When you look at the part of the quadratic formula that is underneath the square root and you look at what does that come out to be by itself, if that comes out positive, you're going to end up with 2 answers at the end of your quadratic formula. And these represent those 2 answers, your 2 real roots. If this comes out negative, you know you're going to end up with an imaginary number because you're doing a square root of a negative. Imaginary numbers mean that you don't have any actual places where the parabola crosses. And the only thing that's not positive or negative, the only thing that's not included here or here, is for the discriminant to be exactly 0. And if this piece comes out to be exactly 0 and you try to do plus 0 and minus 0, you're going to get the same answer either way, and that's when you end up with only one solution. That's when your parabola is just touching the x-axis, okay? So that's the whole deal with what the discriminant does. The discriminant, which is this thing right here, determines how many roots you're going to have and kind of what your parabola is going to look like in general, all right? If you need to actually find what the roots are, you're going to have to bust out the entire quadratic formula. But if it just asks you, you know, what kind of roots are there or how many are there, this would be where you would use the discriminant, okay? All right, so I think I just have one example for you here. I've got a quadratic here, and the very first question says, how many roots does this function have, and are they real or imaginary? So this is the question that you're going to use the discriminant to answer, okay? Which means I'm not doing the entire quadratic formula, I'm just doing this. So I would do negative 3 squared minus 4 times 6 times negative 4, okay? And actually, I can tell right now just from looking at that it's going to come out positive. And that's all I really care about is that it's going to come out positive. But I'll go ahead and crunch the numbers just so I have something to write down. Okay, so this comes out to be 105. The only thing that matters to me is the fact that that's positive. And the fact that that's positive means that I have 2 real roots. Okay, 2 real roots. That's what I really care about there. Then it says if there are real roots, go ahead and find what they are. All right, well, honeymoon's over. If I actually have to find what the roots are, that's where I'm using quadratic formula. All right, so I'm going to have to go back and do the entire quadratic formula here. X equals negative b, so that'd be positive 3, plus or minus. Now the good news here is I already know what this thing underneath the square root equals, right? It's just going to equal 105. So I'm just going to plug that 105 right in there, all over 2 times my a value, which is 6. I'm going to go ahead and just do this one with decimals, because if we're talking about roots, we're talking about places on a graph, and that's going to make more sense. So square root of 105 is equal to 10.25. So I'm going to say 3 plus 10.25 over 12, and 3 minus 10.25 over 12. Okay, let's see. This one works out to be 1.10, and this one works out to be negative 0.60. Okay, and so these right here are my 2 real roots. Okay, so a minute ago when I said I was going to have 2 real roots, this is what they are. If I was to graph this thing, I would see that it crosses the x-axis here and here, meaning it has 2 real roots. Okay, so that's really the big push today, is just knowing this discriminant theorem, that if you calculate just that part of the quadratic formula that's underneath the square root, it can help you decide if you have 2 roots, no roots, or 1 root. Okay, and that's the bulk of your homework tonight, which is Lesson Master 610B, is really just answering this question, 2, 1, or 0. Okay, all right, we will go over this in class some more tomorrow, but go ahead and give the homework a try.